Okay, in the RC circuit shown in the figure below, the battery has fully charged the capacitor. Okay, fully charged this capacitor, and then at 0 second, the switch S is thrown from position A to B. Yeah, thrown from A to B. The battery voltage is 20 volt. The battery voltage 20 volt, and the resistance of the resistor is 57 ohm, and the capacitance C is 1.02 microfarad. Okay, determine the time constant tau, yeah, the time constant, the value of the charge Q on the capacitor at 0 second. Okay, the charge on at the capacitor at 0 second, and the value of charge at 60 microsecond. Okay, so okay, first of all, we should look at these whole questions. These questions is about charging or discharging capacitor. Is it charging or is it discharging capacitor? Okay, so that one we need to identify first. Is it referred to charging or discharging capacitor? Yeah. So look at here. He said initially the battery has already, okay, at 0 second, the charge, the battery has fully charged the capacitor. Fully charged. That means at 0 second, the charge is the initial charge is maximum charge. Okay, it's maximum charge. Initially at 0 second, yeah. So after that, he throw the switch from A to B, because initially you see the switch is connected to A, so it's connected to the battery connected to the capacitor. So we can say that's why he's fully charged already, fully charged. Then he throw the switch to here, to B. Then you disconnect the battery, then start, yeah, that means the capacitor start with full charge, start with maximum charge at 0 second. Okay, and then when you connect to B, this the charge will start to the current will start to flow in the circuit to discharge the capacitor, will flow through the resistor, because when the switch is thrown to B, the battery is already disconnected. The battery is already disconnected from the capacitor, so it's no longer charging the capacitor, and now the charge is starting to the capacitor is starting to discharge. Discharging process, yeah, discharging process happen. So okay, so that's that one I need you to clarify. Yeah, I want you to be clear at that point. So the battery voltage is 20 volt. Okay, so what I can say, when it's fully charged, that means the voltage of the capacitor should be equal to the voltage of the battery. Yeah, at 0 second, which is 20 volt. This is the initial maximum charge. Yeah, that's the maximum charge. Okay, actually I should write this one is actually the maximum charge. Yeah, maximum voltage. It has a maximum voltage. So the resistance of the resistor is 57 ohm. This is the resistor, and we have also the capacitance. Yeah, we have the capacitance also, but in microfarad. So first of all, let's find out what is the time constant. Okay, question A, we need to find the time constant. What's the formula for time constant? What's the formula for time constant? Let's time constant. The formula is RC. Time constant is RC. Resistance times capacitor. Okay, we already have the resistance here, so just put in the 57 ohm, and then capacitance is 1.02 microfarad. So micro, you need to change to exponent -6. Change to SI unit. Okay, so micro is exponent -6, and let's calculate. Yeah, 57 multiply 1.02 exponent -6. So I got the time constant is 5.814 exponent -5 second. That's my time. Okay, so my answer is correct. Okay, my answer is correct. So and then let's next questions. So look at B. So at 0 second, he mentioned that what is the charge at 0 second? Okay, what is the charge at 0 second? Okay, so what is the charge at 0 second? So as I said, at 0 second, you see here, as 0 second, the battery has already fully charged capacitor. That means at 0 second, it should have the maximum charge. Actually, I should write like this. I should write initially at 0 second, the charge is maximum charge. Oh, sorry, is maximum charge. So Q0 means maximum. Yeah, Q0 means maximum. Yeah, and also the voltage of the, yeah, this one I should write also. At 0 second also, the voltage is also maximum. Yeah, the voltage of capacitor is also equal to voltage of battery, so it's also maximum voltage. Okay, so okay, B, what's the charge at 0 second? What I can say is the charge is at maximum. Okay, but we don't know what's the value of the initial maximum charge, isn't it? So how to find that out? We have we can use the formula Q equal to CV. Q equal to CV. We have the C capacitance value. Yeah, capacitance value. We also have the initial. This one, V 20 volt. This 20 volt is this 20 volt is actually the initial maximum voltage. Okay, maximum voltage. So this is the V naught. Okay, hold on a second. Yep. Right. Okay. So what is the C value here? C value is 1. I need to change the C value to farad, yeah, instead of microfarad. So exponent -6 farad, and then initial voltage is 20 volt. Q equal to CV. I will get the initial charge. Yeah. Okay. So what's the value? Okay. Alright, so I got 2.04 exponent -5 coulomb. That's my answer. Okay, so is that correct? My initial charge at 0 second. Yeah, 2.04 exponent -5. Yeah, -5 coulomb. That's correct. Okay. So finally, what is the charge at 60 microsecond? Okay, so we can see that this one at 0 second, the capacitor start from fully charged, and then once it disconnect the battery, the charge start to flow through the resistor. So this is a discharging process. What I can say, we must identify, is this charging or discharging process? So this is a discharging process. Okay, so this is important. This is a discharging process. Once it connect to here, to the point B, yeah, once you connect the switch to point B, then the discharging process happen through the resistor, yeah, because the battery already disconnected. Yeah, battery already disconnect. No more charging, yeah? No more charging. Okay, so let's find out. So question C is a discharging process. Discharging process. So we want to know what happened to charge at this time at 60 microsecond. So we use the formula for charge. We use the formula for charge in discharging process. Okay. Okay. One thing we know about this one. One thing. Okay. You see that this one. You see charging and discharging. One thing we know about charging is the charge voltage increase, current decrease. But discharging process, all factors decrease. Yeah, that means all charge, voltage, current decrease. So this is how I remember the formula. Okay, so discharging process, what's the charge formula? Yeah, I always remember like this. I always back to this. Okay, I want you to know this also. Okay, back to remembering the formula, charging and discharging. Okay, charging and discharging. We have charge, voltage, current. Charge, voltage, current. It's important to know whether this process is charging or discharging process, because we need to know what's the formula. Okay, so we know that if charging process, this charge and voltage will increase, okay, but current will decrease. Current will decrease no matter charging or discharging. No matter charging or discharging, the current always decrease. This is something special. Yeah, something special. Only the current will decrease no matter charging or discharging. But the charge and voltage different. Yeah, charge and voltage increase, but discharging, charge and voltage decrease. Okay. So only the charge and voltage opposite between charging and discharging. But for current, it's always decrease no matter charging or discharging. Okay. So why is this important to know whether increase or decrease? Because this increase and decrease help us to determine what formula, what is actually the formula to use to solve the questions. Okay, like I always remember, if increase, I always, okay, if increase, yeah, I remember like this. How to remember the formula? If increase, I always use 1 minus epsilon. Okay, 1 minus epsilon. If decrease, I always use epsilon. That's a formula. Okay, so what I can say is the formula for increase, this one must okay, I don't want to write I already explained about all this in the concept videos. Okay, so I don't want to repeat that. Okay, right now what I can see, this is a discharging process, and then you are talking about charge. You are talking about charge. Yeah, so I want the formula for charge only. Yeah, I only concerned about formula for charge. So what's the formula for charge? Q equal to Q naught. Then what to write? What to write at? Is it using 1 minus epsilon or epsilon? Which one? So right now I know for discharging process, the charge is always decrease. Charge is always decrease. So charge decrease, that means I'm going to use exponent or epsilon. Yeah, I'm going to use epsilon instead of 1 minus epsilon. The formula is epsilon. Okay, so the formula is epsilon. Because it say is decrease is epsilon. Okay, and then over here, what should I write? Over here, I should write the same thing again. Is negative time over RC. So that's it. That's a formula. See that? That's how I remember this formula, this complicated formula. See that? So I remember this. So it's epsilon. So right now, anyway, do you know that this part RC here is actually time constant also. It's also time constant. I also can write this formula. I also can write this formula as Q naught and then exponent negative T over time constant. Okay, T over time constant. I can write that also because I already got the time constant. I already multiply RC. So here I just substitute time constant lah instead of substitute the RC again. Okay. Alright, so now I can substitute all the value. I already have Q naught. I already have time constants. Right now I just need to find, time is 60 microsecond. Put inside. Then I can find the charge at this time. Okay. So okay, my initial charge is 2.04 exponent negative 5. Okay, column, and then exponent negative time is 60 microsecond. Micro is exponent negative 6. Okay, okay, microsecond, and then over, okay, what's the time constant? Time, okay, 60 microsecond, 60 micro. So I need to change micro to exponent negative 6, and then time constant is 5.814 exponent negative 5. Okay, 5.814 exponent negative 5 second. Okay, so what's the answer? Let's calculate. Okay, let's calculate 60 exponent negative 6 divided by the answer 5.814 exponent negative 5. Okay, and then what's the answer? Exponent negative answer. Okay, and then 2.04 exponent negative 5. Multiply answer. Okay, my answer is 7.27. Yeah, 7.27 exponent negative 6 column. Is that right? Yes, that's the answer. 7.27 exponent negative 6 column. That's correct. Okay. So that's how I do it. Okay. So I always identify this discharging process, and I need to use the formula for charge. So I just write discharging charge, and for discharging process, the charge always decrease. If decreasing formula, always use exponent. Yeah, because for formula for increase, if formula increase is 1 minus exponent, but for decrease, the formula is exponent. So now I know the formula is using exponent because the charge decrease, so it's exponent. So the rest I can know. So this is how I remember the formula, and then the rest is substitute all the value that I gotten earlier, and I got the final answer. Okay, so that's how you do the these questions. Okay, see you in the next video.